Principal sir.
Good evening, madam.
Good evening, sir. Just we'll take few minutes, sir. We'll start.
Sure. Okay.
Good evening, sir. Jayari, sir.
Good evening, ma'am. Good evening, principal sir.
Good evening, sir.
Good evening, all the participants.
Good evening, sir.
இந்த பில்டிங் கட்டுறதுனால உங்களுக்கும் எனக்கும் தான் பெனிஃபிட்.
క్లాస్ అవుతున్నామే అందుకని. Okay, ma'am, we'll start in few minutes. We'll wait few more minutes, like 4 minutes. We'll wait and we'll start now.
Sure, sir, sure. Just by sharp 6:10, I'll start this.
Okay, ma'am. Yeah. Chandra Reddy, sir. Good evening, sir.
Yeah. Hi. Good evening, sir. Jay Sri Doctor. How are you, sir?
I'm fine, sir. Thank you.
Good evening,
Your voice is breaking, sir.
sir.
Your voice is breaking.
Okay. Can you try it now, sir, properly?
Kalpa ma'am, can you hear his voice?
Can you hear it properly, sir?
Hello, sir. It's audible, sir. But little
Okay,
bit.
okay.
Yeah.
Okay, great. Okay.
Yeah, we'll start session exactly at 6:10, sir. Just we are waiting few more participants to join. You will share the PPT, sir. Otherwise,
It is a large PPT. Can I share you after that? If you
yeah,
don't
no
mind.
problem. Then
Okay.
I will make you will be the presenter.
Okay.
Chari, sir. Sidham Chari, sir.
Sir, చెప్పండి sir.
Yeah, can you make Chandra Reddy Bogireddy, sir? Can you make him as a
Okay, sir.
presenter? Or once after Kalpana's speech, you can make sir as a presenter. Okay?
Okay, sir. Okay, sir.
Chari, sir, make Kalpan madam as a host.
Already done, sir. Kalpana madam is also host.
He's also host. Okay.
Kalpana madam, Samyukta madam, Anil sir.
Right. Srinivas Reddy, sir. Good evening, sir.
Sir, good evening, sir.
Jayari, sir. Jayari, sir, am I audible?
Yeah, you're audible, ma'am. You can just start.
We'll start the session, sir.
Yeah.
Good evening, everyone. It's my privilege and pleasure to welcome you all, the participants and resource persons and dignitaries to this AICTE Atal Online 6 Days Faculty Development Program. on harnessing sustainable energy for climate resilience. Myself, this is Kalpana, Head of the Department, Mechanical Engineering. And this initiative reflects our commitment to academic excellence and our professional growth. As educators, we play a pivotal role in shaping the future generations, and programs like these equip us to stay at the forefront of the innovation. Here, KG Reddy College of Engineering and Technology is one of the leading institutions to support this kind of activities, and it was established in the year of 2008. And it is approved by AICTE and affiliated to JNTU Hyderabad. And it is conferred autonomous status by UGC from the year UGC autonomous from the academic year 21-22 and accredited by NAC A+. And here almost 80% of the departments are accredited by NBA. And also KG Asset is approved business incubator from MSME and as well as approved institution innovation cell from MHRD. And as well as KG Asset is recognized by Scientific and Industrial Research Organization, and it was founded and managed by the Aristotle Educational Society and known for its commitment to offer world-class engineering education with the quality of technical teaching and best infrastructure. Coming to the Department of Mechanical Engineering, it is one of the core branch in KG Asset and established in the year of 2008. And here department is started with intake of 60 and department is accredited by NBA, National Board of Accreditation, and it is equipped with well qualified and dedicated faculty members to train the students towards their holistic development. This faculty development program on harnessing sustainable energy for climate resilience is designed with advanced knowledge in sustainable energy, green technologies, and as well as climate resilience. Over the next week, we will explore the topics from renewable energy and as well as energy efficiency, green building materials, and sustainable urban development. By end of this program, I am confident that you will have actionable insights to enrich your teaching and as well as research practices on the same. So with this great enthusiasm, I declare this faculty development program on harnessing sustainable energy for climate resilience is officially open. So let us embark on this journey of learning and as well as growth together. Now, it's my privilege to introduce our principal, Sir Dr. Sai Satyanarayan Reddy. Dr. S. Sai Satyanarayan Reddy, our principal and professor from Department of Computer Science and Engineering, has 29 years of teaching experience, including 10 years as the principal. He joined in the KG Reddy College of Engineering in the year of 2023. And Dr. Reddy holds a Bachelor of Engineering from RIT and a Master of Engineering from BITS Pilani and a PhD in data mining and completed his postdoctoral fellowship PDF at California Public University. He was a ratified professor in CSE from the JNTU Hyderabad and also a senior member of IEEE. A fellow of IETE and Institute of Engineers and a life member at CSI and as well as ISTE. He has published over 80 papers in Scopus, Web of Science, and SCI journals under his guidance, he has 3 scholars awarded as PhDs and as well as 3 more currently pursuing the PhD. With this short brief introduction, I warmly welcome our beloved principal, Dr. Sai Satyanarayan Reddy, to address this gathering. Sir, please welcome, sir.
Hello.
Hello.
Yeah.
Hello, sir.
Hello. Can you hear me? Hello.
Yes, sir. You are audible.
Hello. Can you hear me?
Yes, sir, you're audible, please.
Yes, sir. You are audible. Hello.
Hello.
Sir, you are audible, sir.
Hello. Yeah.
Sorry.
Yeah. Okay. Good evening to all of you. Very happy to see Department of Mechanical is conducting 1-week workshop on faculty development program on harnessing sustainable energy for climate resilience. And thank you, Kalpana, for giving great introduction about me. And thank you, Dr. L. Jehari sir, Dean R&D, Professor mechanical engineering, and combinedly with the coordinator, one of the coordinator, Mrs. P. Samyukta, heads CAST, Assistant Professor, Department of CSC, co-coordinator, FDP, and congratulations to the FDP, which is very much required nowadays about the leveraging sustainable
గుడ్ ఈవినింగ్ చెప్పండి
energy.
చెప్పారు
Can you hear me?
మిమ్మల్ని వస్తున్నారంట కదా, విజయనగరం
Sir, you
అంటారు.
are audible. Someone,
Hello?
I request someone to be mute.
ఓకే ఓకే వచ్చేసేయండి.
Hello.
Hello?
Yes, sir. Yes, sir.
Okay. Again, I welcome all the
మేమే ఎవరిని అడగలేదు.
I welcome all the participants to this FDP program, and I hope there's a good takeaway to all the participants, and there may be wonderful sessions throughout these 5-6 days. And this is very much essential nowadays because the leveraging of sustainable energy for climate resilience is very, very important. And a lot of research is happening in this area. I encourage all the faculty members to participate in fuller extent and get the good benefit out of all the speakers and interact sessions and get good sound knowledge and perfect to the students community. And wish you all the best. Thank you. Thank you very much.
Thank you, sir. Thank you for giving great motivation and as well as delivering the importance of this FDP Faculty Development Program. Thank you, sir. Thank you so much once again. With this, now it's my pleasure to introduce our Vice Principal, Dr. M.N. Narsaya. Dr. M.N. Narsaya is a professor of Electronics and Communications Engineering, has overall 20 plus years of teaching experience, and he joined in KG Reddy College of Engineering in the year of 2013. Dr. M.N. Narsaya holds a Bachelor of Technology from JNTUH and Masters of Engineering in VLSI System Design, and completed his PhD in adoption of wavelet transform for CT and MRI image fusion at JNTU Hyderabad. And he published over 22 papers in Scopus and SCI journals. Currently, he is serving as a Vice Principal and as well as Dean Academics at KG Asset. With this short note, I request Dr. M.N. Narsaya to speak few words about this faculty development program. Narsaya sir, please welcome.
Yes, ma'am. Thank you for nice words. I hope I'm audible.
Yes, sir, you are audible.
Yeah. Thank you, Kalpana, ma'am, for those nice words. Good evening, all, particularly the participants who are attending this particular FDP. When I look at the title of this particular FDP, I was referring the dictionary to understand harnessing and resilience. So interestingly, the meaning of harnessing, it came to a conclusion like how do we make use of the sustainable energy to control the climate actually, because India is a country where we have a lot of natural renewable resources, but we do not have technology. Yeah.
Sorry to interrupt you, sir. Your voice is not audible.
Hello. Now it's clear. Hello.
Yes.
Ma'am, Kalpana ma'am, now it is clear.
Hello.
Yes, it is
Yes,
audible,
sir.
sir.
Voice
Please
clear,
continue.
sir.
Yeah.
Yeah. Thank you. Yeah. The title, when I'm talking about title, harnessing sustainable energy for the climate resiliences, there's a lot of meaning we have in this title. When I say harnessing sustainable energy, it means like how you're going to make use of the sustainable energy. As I mentioned, India is a country where we have a lot of natural renewable energy sources. It's up to our technical team of India how these natural renewable energy sources can be converted into the technology to solve the different kind of problems. When I say resilience, it's an ability to adapt and recover from the climate related events like floods and the drought. Whenever there is a drought, whenever there is a cyclones, whenever there is unexpected climate changes in the different states, yes, whatever the natural renewable energy sources we have, maybe these energy sources should help us to recover the country as soon as possible so that we can continue our regular activities. So this title exactly suits for the situation. Hope the different sessions plan organized in this particular six-day FDP will really explore all the participants to the next level to make use of the renewable energy sources to control the climate changes in India. I can also say India is a rich country with the poor people. Having said that, when India is a rich country, why the people of India is poor? It's only the simple meaning, as we have very good natural resources, natural renewable resources, but we do not have technology to convert these natural resources to solve our real-time problems. Hope it's a great initiation from the Department of Mechanical, and I congratulate the department and particularly the coordinators of this particular FDP, Dr. Jayahari sir, the Dean R&D, and Professor Samyukta ma'am, Head for CST of KG Reddy College of Engineering and Technology. So with these few words, I welcome all the participants. Hope whatever the learnings we have through this particular six-day FDP, let us try to, after these learnings, let us go back to the institutions, share our reflections with the students and faculty, so that somewhere we need to understand what kind of resources we have in India and how these resources can be useful to solve the problems related to the environmental changes. So thank you once again. I congratulate all three of you and the Department of Mechanical Engineering to organize such an FDP. Thank you, ma'am.
Thank you, sir, for delivering its importance of this harnessing sustainable energy for climate resilience. Thank you so much.
Thank you.
Now, I'm happy to introduce our coordinators, Dr. L. Jayahari and our co-coordinator, Mrs. Samyukta Penta. Dr. L. Jayahari, he is currently professor in the Department of Mechanical Engineering and also Dean R&D Research and Development in KGRSET, KG Reddy College of Engineering and Technology. So, sir is having vast 22 years of experience and published a number of papers in various SCI journals. Now, I'm requesting our coordinator, Dr. L. Jayahari sir, to speak few words regarding this FDP, and also I'm requesting to give the instructions to the participants as a coordinator. Jayahari sir, over to you, sir.
Yeah, thank you, ma'am. Thank you for your words. And I'll thank you all the participants who are joined. This is Dr. Jayahari. Just I want to speak few words. Already Principal sir and Narcis sir and Kalpana madam given the instructions and about the FDP. So, see, when we have discussed this FDP, me and Samyukta madam was working on this on sustainability and also climate change energy. Based on that, we selected this topic so that it will be more useful for the society. So this kind of faculty development where we can share not entire knowledge, but at least some knowledge to the faculty so that they can be the part of this society development. As Narcis sir said, we the people where we are rich in resources but poor in the innovation part. So make sure that useful of use our resources and make our nation the great nation. So based on that, we selected and we have applied for this FDP to the AICT. And we proudly say that KG Reddy College of Engineering and Technology have received 2 FDPs from the AICT Atal FDP. Out of 5,500 has been selected, and two are from this from our college. So it's one of the good achievement from the college. At the same time, we have the faculty where we can working on that one. We have a center called the Center for Innovation and Social Transformation, where particularly Ms. Samyukta is working, and she's the head for the center, where we are focusing on the sustainable environment. At the same time, we are doing projects. We are visiting various villages in and around our colleges, and based on that, we are working very close to the environment and also the climate change, and also this kind of sessions where we have already conducting in the institute level and also to the society, to the nearby colleges. Yes. So this we can say that it's a platform where faculty is easily can know the points from the various speakers which are going to learn from this 6 days. It's a great honor for us to host this FDP sometime. And really happy that around 120 faculty have been registered for FDP, so that it's a great learning for everyone at the same time. We see that the same changes we can see with through this learning, we can pass to our to the students and at the same time to the society. Okay, so this is a few points I want to share to all the participants, and thank you, Kalpana ma'am, principal sir, and Narsi sir for joining these sessions. And also, as Madam said, I want to give few instructions. At the end of every session, now we'll have a attendance session will be there. At the same time, feedback session is there. So 2 forms will be generated. Today's we have our moderator. They will share these links to all the faculty, all the participants, so that please try to fill the forms of the attendance and also the at the same time the feedback. So every session we'll have this session, the feedback sessions. At the same time, session 1 and session 2, both the moderators is going to take care of these things. And at the end of the FDP, every faculty has to share one minute video. Okay. At the same time, they should write the exam without failing. Okay. And also they have to maintain minimum of 80 to 90% attendance. So minimum 80% should be maintained so that they can be receive this certificate from the AICTE. So these attendance will be very, very important. So make sure that faculty should attend, and I'll feel that they'll know, as a faculty, we know the importance of attending these sessions at the same time. And we to get the certificate, this mandatory, the AICTE is they given send a mail that every session they're asking for the attendance. Okay, so these are the some of the few points I am sharing in the course. Day 1, day 2, day 3, and day 4. Every day we'll give this important sessions. We'll also give the instructions to the participants so that they know exactly what to do for this coming days. Okay. Thank you, ma'am, Kalpan ma'am, and all the best for all the participants who are going to join, and and welcome you all this wonderful FDP for this 6 days program. Thank you, ma'am. Thank you very much.
Thank you, sir, for giving the brief instructions to our participants. I hope they might noted all these things. Now I want to introduce our co-coordinator, Mrs. P. Samyukta, and she's the head CIST Department, Center for Innovation and Social Transformation. And she's currently working on the social innovation related projects, and recently she received the international award on the same in Australia. And now I request Mrs. Samyukta ma'am to speak a few words about this program. Then we'll start the program. Samyukta ma'am?
Yes, ma'am.
Yeah.
I hope I'm audible.
Over to you, ma'am. Yeah.
Yes. Thank you, madam. Thank you for the introduction. And good evening to all participants. And thank you, Principal Sir and Vice Principal Sir, for joining this FDP. Before going to start our program, I want to set a tone for this FDP. Actually, recently we received, KGRSET received Cancer Global Sustainability Award. We received this in Australia. So out of 24 countries, the KGRSET is recognized as the first one under sustainability practice. As a faculty, first while starting this sustainable energy title, we thought of I'm discussing with the coordinator, Dr. L. Jayahari sir. So sustainability means most of the faculty are not interested because the technology right now is in AML and data science. So how we can address this? But I'm happy we decided to conduct this FDP, and I'm happy almost 120 participants registered for this FDP. So for that, I'm thankful to every participant who are joined here. And I'm giving assurance at the end of this FDP, most of the faculty are trying to implement these sustainable practices at your colleges. So before starting the session, I want to tell only one thing. Always the change starts from us. So everybody talking about climate change, sustainability. So now every human being is facing a problem of changing of a climate. Sudden increasing of temperature, sudden rainfall, sudden winter. So we are facing a problem. But is it anyone think about how to address those challenges? So as a faculty members, I believe we hold a position in shaping the mindset of our students. So changing students' attitude towards the sustainability is in our hands. So by integrating these critical concept into your curriculum or giving some practices in your colleges, we can inspire them to adopt these sustainable practices in their daily lives, and we can become good generation. We can give good generation to the next. So with these words, I am handovering session to Kalpana madam. Thank you all the participants for joining us. And next sessions, we have good interaction sessions. So let's learn from each other. And together we can cultivate a generation not only understands, we will see the sustainability in action. Thank you.
Thank you, Samyukta ma'am, for delivering the importance of sustainability. Yes, as you said, AI and ML are trending, but even though to protect our future generations, climate resilience, sustainability, these concepts are very important nowadays. I believe our world is moving behind this also. So this is one of the important topic. Thank you, ma'am. Thank you so much. Now it's time for closing the formal inaugural ceremony. So let me thank through the formal vote of thanks. So respected dignitaries, esteemed guests and resource persons, faculty members and dear participants, it is indeed a privilege and honor to extend this vote of thanks on this special occasion. On this special occasion inaugural ceremony of 6 days online Atal FDP program on harnessing sustainable energy and climate resilience. So first and foremost, I extend my heartfelt thanks to the management of the institution to support us everything required to conduct this kind of huge program. And I express my sincere thanks and heartfelt gratitude to our beloved principal, Dr. Sai Satyanarayan Reddy Garu, KG Asset, for gracing this occasion with their presence and inspiring with the inaugural words. And also I extend my sincere thanks to Dr. M.N. Nasaya, Vice Principal and Dean Academics, for their continuous support. Your guidance is a constant source of inspiration for us, sir. Thank you. And a special note of appreciation to our resource persons, today's resource persons, Dr. Chandrabogi Reddy Garu and Dr. Taruvira Venkata Marthi Suman Garu, for generously sharing their time and expertise in today's sessions. We eagerly look forward, sir, to your sessions, which I am confident that which will enrich us with the knowledge and as well as the skills needed to excel in our professional careers. And also I am deeply grateful to our coordinator, Dr. L. Jayahari Garu, and as well as our co-coordinator, Mrs. Samyukta Garu, for their unwavering support and for fostering a culture of continuous learning through these initiatives like Atal FDP programs. And a special heartfelt thanks to our organizing committee for their meticulous planning and as well as seamless execution of this event. Your hard work behind the scenes has ensured a smooth and as well as successful inauguration. Last but not least, I extend my gratitude to all the participants who are joining for this session and showing enthusiasm for this faculty development program. And your active participation will be assured undoubtedly make this program a grand success. So on behalf of the department and as well as the organizing team, I ensure that this faculty development program will be engaging, insightful and transformative journey in all the way. Once again, thank you all for being part of this event. So let us look forward to a fruitful and as well as rewarding sessions. So thank you. Have a great day. Now I'm handing over the sessions to our today's moderators. So Mr. Satish and as well as Mr. Anil, the assistant professors in the Department of Mechanical Engineering. Satish sir, are you there?
Yes, ma'am.
Satish sir, over to you, sir. Please start the sessions by introducing our today's resource persons.
Okay, ma'am. Thank you.
Thank you, sir. Thank you.
Good evening, everyone. Myself, Satish Singh Arapu, Assistant Professor in Mechanical Department. It's my pleasure to welcome you all for today's session on climate resilience and adaptation, preparing for the future. It is my honor to introduce our esteemed speaker, Dr. Chandrabogi Reddy. He is currently a foreign scientist at the Academy of Logistics and Transport in Almaty, Kazakhstan, and a visiting scholar in the Department of Civil and Intelligent Construction Engineering at Shanti University in China. Previously, he served as an assistant professor in the Department of Civil Engineering at Vardhaman College of Engineering in Hyderabad. Dr. Chandrabogi Reddy holds a PhD from Sardar Vallabhbhai National Institute of Technology, Surat. He is having over 19 years of rich experience in academia and research. During his research, He received 2 Best Papers awards at national conferences and delivered 32 guest lectures in national and international seminars. He published 30 research papers, 5 patents, and 2 books. He also served as the chairman of technical sessions and evaluator for the poster presentations. Currently, he is an active reviewer for the Advances in Science, Technology, and Engineering Systems journal, ASTESJ USA, and as well as Sustainable Civil Transfer Infrastructures Springer Journal. He holds the position of honorary editorial board member, consulting editor for Innovative Scientific Research Professional Malaysia. His areas of research interest includes basic geomechanics, sustainable and carbon reduction ground engineering, numerical modeling, image analysis, and many more. So he is the member in various professional bodies. With this brief introduction, I'm handovering this session to the Dr. Bogreddy, sir. Sir, welcome, sir.
Yeah, thank you so much for inviting me here. And thank you so much for all the organizers who is organized this session. And my special thanks to the principal, sir, as well as head of the department and research dean and the coordinators and all the participants who are joined here. I'm really thankful and really happy to see this particular title. Because even I'm currently working on the sustainable development goals exclusively on climate change. So even I'm currently working on the multidisciplinary research. So that's I'm felt very happy to share some of my research topics with you and some of the multidisciplinary research activities with you all. So with that small things, I will share you my session. And before that, one of my student and colleague from USA, she is Varsha. She is currently working in the climate change in USA, and she is a UN member also. I mean climate action. So she will just share 5 minutes about the what is the climate and what's currently she is working on. Then I will start my session. Varsha, can you play? She is my student and she will introduce herself as very briefly. Then I will start my session. Dear Varsha, can you please join?
Hello, good morning, good afternoon, wherever you are. So I'm actually based in the Caribbean, but it's all part of the Americas group from Trinidad and Tobago. And thank you for having me here today. I hope you're hearing me very well and clear. Can you confirm?
Yes, please
Yes,
go ahead.
yes, ma'am, you are audible.
Okay, great, wonderful. All right, so basically, because Trinidad and Tobago is a small island developing state, and we have been feeling the effects of climate change in all aspects, both in the physical environment and on the socioeconomic aspects as well. Neighboring Caribbean islands also are feeling those effects, especially with the extreme weather events that have been occurring. And I'm sure, wherever you're coming from as well, nowhere on Earth has been spared from the effects of climate change. So I'm working on the effects of climate change and preparing our future generations for the energy transition, advocating for cleaner sources of energy, and ensuring that, energy, which is a basic necessity, is met for or is, equally accessible to all persons, because there are just 2/3 of the world population that is accessing affordable and clean energy, in that aspect. My other focus is also on sustainable cities as part of the 17 SDGs and clean access to water as well. And I look forward to the rest of the sessions. Please feel free to reach out to me if you have any questions. Is that okay for you, Dr. Bogreddy? Should I elaborate on anything else?
Yes, ma'am.
Yes, please go ahead.
Okay. So thank you for having me, and I
Yes,
look forward
Varsha.
to the rest of the session.
Yeah, this small introduction. Yeah, thank you, Varsha. Thank you for joining here. So today we are working together about the climate change exclusively on the plastic waste. And she there in particular her location, we face the problem with the bitumen. So how we can utilize those bitumens as well as the plastic to keep the sustainable way. So in this my particular session, I will try to share about the how we can adapt the climate actions, all these things, and one of few of the new materials how we can use these things in the civil engineering construction practice. As per the multidisciplinary research, so we can deal with the agriculture point of view, geotechnical construction point of view, as well as the when you are installing the pipeline system, how we can what are the problems we are going to occur. Those things I will try to share here, as well as the I will try to share about the how we can do some paid works about this particular climate action research with the international collaboration. Those things we will try to discuss here. So these are the current my working places. So currently, I'm working here in Shanto University, and I have some research collaboration with the in Thailand. So one of the professor, we are both working on the agriculture point of view. So here I worked previously. So this is my current research work is going on here with my UC and PhD students. And few of the PhD students are working on the climate action as usually on a geotechnical point of view. So these are the students in different places. So these are from Shanto University, China. This is one of the our things. So this is my one of the book. So these are the students at different places. This is one of my research. So it is on the climate action about the oceans. So once the sea levels is going to rise, so what are the precautions we can take? So those things we can do. We have done some research work and we published the papers. So suppose there is some salination and different climate action. Sorry, how the soil is going to behave with the climate changes. So suppose you can keep the soil in the laboratory like is minus of 40 to the plus 50. How soil is going to behave. Those things we worked in our laboratory, Kazakhstan, as well as colleagues. So these are the academic deans and research coordinators, all this here. So actually, the multidisciplinary research point of view, currently, I'm a geotechnical and civil engineering point of view. So we currently working on the multidisciplinary research, exclusively while dealing with the climate action. So even that is a agriculture point of view. So as a even by using how we can control climate changes. So these are the equipment is in Thailand. So it is a dynamically we can see the adoption of the how the soil is going to behave. And currently we are working on this particular beach soil. So these are the multi goals. We can't publication point of view also. We need to keep the with sustainable development goal. It can be adapted. So actually, as when you are publishing the paper in introduction as well as the abstract, it is mandatory to mention which sustainable development goals is going to useful for your paper.
Chandrareddy sir, your voice is breaking.
If you see the whatever you can do is mean that keeping these sustainable development goals. So even the initial the particular these this might be small things to be okay. Yeah. It might be very multidisciplinary way. By adopting this climate change, so those who are in geotechnical, or those who are mechanical, or those who are from electrical, so they can adopt the this particular sustainable development goals, and they can work on the particular area. So one of the key parameter because of the climate change is the carbon carbon emission. Well, all the sectors, all the branches, we are mainly focusing on the how we can control this particular carbon emission. So see, this is the funny, but you know,
Excuse me, sir. Your voice is not
okay,
clear.
sorry, I think my audio is not good. I hope it is okay right now.
There is a lag in your voice.
Oh, okay. I will just check the mic then. Okay. I think some issues. Can you see, is it okay right now? Hello?
Hello, sir.
No, it's still sounding very distorted.
Is it okay? Okay. Now I will use my mic. Yeah. Is it okay now? I'm changing to my mic device. Is it audible, my voice?
You're audible. Please go ahead.
Okay. Thank you so much. So recently we have published, we have one meeting in the international and we shared about this particular, slide. Very interestingly, so there is a carbon emission is going to occur, but the challenging, who will capture these particular emissions? So we are all research scholars, and it is our present time to capture these particular emissions, exclusive emission by the different sectors. As from a civil engineering point of view, if you see the structure, I mean, when you construct structure, we may face a lot of pollution, and as well as when you're creating the cement, by in the factories, there is a huge amount of the carbon emissions going to occur. So this all the factors will influence the climate change. So to all this, so anyhow, we have to build the infrastructure and we have to build the proper, our research things. But how we can control these things means that even all the national and international peoples that are working from the UN nations as well as the so this particular climate action people they're working on how we can control this carbon emission. If you see the is all these things now they are giving like rating. Suppose if there is a possibility of reducing of the carbon emission, so even you can optimize the current charges also. So, but who can ensure the all these things? Who can create the awareness means that as a climate action people, we have to take those challenges and we have to give the more awareness to the people. So this is one of the biggest challenge in the climate, action. Sorry. So what are the issues is going to occur, particular this climate changes mean that mainly if you see the climate because of this particular climate, mainly those in coastal zones land is going to affect particularly in coastal zone. Especially in India, we are losing our land from the coastal zones as well as the Himalayas zones. So I hope you might be almost nearly 2 inches still in the Himalayas zone. When it comes to the coastal zone, again, it's the same issue on the climate issues because of the snow is melting. If you see even in Kazakhstan, whenever I visited a few sites and construction sites in Kazakhstan, my professor colleague used to say that Dear Chandra, once upon a time here is a snow, is a huge amount of snow is there, but now it is completely melting. So once it is a melting, where it is about to reach, which means that actually anyhow it is going to reach the oceans, you know. So then again problem with the oceans is going to sea levels is going to rise, you know. So then if you see the with respect to time, very you know our ancient time to till right now, the oceans sea levels is rise so high. Because of this reason, there is a erosion is going to occur in particularly coastal zones. So how we can adapt is mean that in our laboratory we create the biocementation material. It will efficiently can control the pollution as well as. So those materials, how it going to affect it, those things I will share in my session. I mean, in the resilience of the climate changes, we have to adapt to the particular situation, and we have to go for the creativity things to to overcome the particular climate changes. So this might be effect on the many climatic things. So exclusively biodiversity, increase the water level and flood scarcity. Uh, just few days back, we have heard about in Los Angeles. There is a fire. Things is going to happen. The similarly, same time in Indonesia also, there is a huge floods going to occur. So these are all the things because of the climate changes. So see, once upon a time, I will show you one of the graph about the climate, how much we change it till right now, because these oxygen levels will completely indicate about the or even our body structure also, as a human body structure also. If you see, oxygen levels is more, then our body size also increase a lot. If you see the ancient time to our generation people, the body of our structure also changed because of the oxygen levels. If it is high, then our body size will increase. If you see the ancient time to here, he's a huge giants maybe there in the dinosaurs kind of time. Those time oxygen is very high. Now the oxygen decrease rapidly, and the researchers and they give the alert about the last few days, few decades, like the last 10 years, the climate change rapidly is increasing. So we need to address all these things, and we have to create some equipments or patents kind of things, how we can work all these things. So even now we are even working on the moon soil. So how we can we are recreating our laboratory this moon soil. So in future we may be moving to the moon or Mars, those locations, because here is the climate is extremely going to change. It is not about if you are going moon and this place is safe. It's not like such opportunity in the different planets. Once upon a time, it's a completely we are came from the caves. Now we are in the concrete caves. But our future is the space. So this is the way we have to work on it. Accordingly, we have to work on the multidisciplinary research. Even now, I'm working in the at a different point of view, like a moisture sensors, all these things. So once upon a time, the course mean that only we restricted with the geotechnical, civil engineering, mechanical, different this way. But now the current scenario completely changed. We have to work on the multidisciplinary research. We need to adapt with the mechanical, ECE, civil, as well as the artificial intelligence. All the things we have to merge into our particular research. So that's the reason even we have the students we choose in our research. So those are different section students who are going to join in our team, and we are all working together. So recently we published one paper about the artificial islands. If you see in the in China, there are so many artificial islands they are going to create. Even Dubai has seen so many artificial islands they created. Even for India, we may be required these artificial islands also, because if you see in the Kerala, this coastal zone, water level is going to rise. So we have alternative options for the population. So those all the things we have to keep in mind when we are going to our research. If you see the chart box, this particular graph about the how this global temperature is going to vary from the from 1951 to the 2020. So till 1970s and 1980s, those who are 18th generation, they might be noticed about the climate, how the climate is very normal. But from 19th, 18th century till now, it is till 2024, we have seen the large variation about the temperature variation. So who will adopt all this system, and we can control this thing, means that we have to work on this particular variation, and we have to create the new material. So for example, steel, we have to create the artificial steel. In geotechnical point of view, nowadays the sand is very very difficult to get the sand. So that is the reason we are currently working on the artificial sand. I hope you might be seeing in the construction practice, everyone is using the dust, that is artificial sand. Maybe some alternate material is required to ensure to safety about the our Mother Earth. If you see the climate action, since this data is since 1976 to 2024, there is a huge temperature is rising. Even see, if you see the 1992 to till right now, the temperature is critically changed. So we need to, who can address all these things, mean that as a researchers, we have to adapt to this particular climate change, and we have to create a new material instead of the digging the soil, instead of the digging into the Mother Earth. So for this purpose, we had done research about the MICP and biochar. These two materials is one of the biodiversity materials. So we have done this particular research in our team, particular sector, in my batch. So one of the main criteria here is when you are rising the sea levels, so there is a possibility about the coastal erosion. How we can control those things? We address in particular research. So in the particular coastal zones, we can modify those coastal soils wherever we are utilizing the pipeline system. As I said, mechanical, they might be what is the corrosion, how much corrosion is going to with respect to time. Even this particular biochar and the MICP material combination, we can control the corrosion also, particularly the steel pipes. So even if you are using the concrete steel pipes as well as the fuel steel pipes as well as the plastic pipes. So when you are changing into the transporting the two materials from one location to another location, so there is a possibility of settlement particular area. So those things we can overcome by using these two materials. So these are the when you are creating these two materials, we can optimize the climate issues also. If you see in India infrastructure, we have the large large growth potential about this. So these are the newly planned government affiliates and adapted this particular system. So this black existing pipeline system. So these are the gas pipelines. So if you see the entire network, we had large potential about the to adapt to this particular gas pipeline system when you are dealing with these particular coastal zones. But this coastal influence is going to occur and the sea levels is increasing. So we need to address how we can adapt this particular new research. So those things I will share here in this particular session. So these are all the pipeline system. This is captured by the ministries, Indian ministries. So this is one of the material about the biochar. If you take and another material is the MICP. So this is another material. So by using these materials, we can strengthening the sand and we can adapt in the pipeline system as well the infrastructure. So and exclusively there is another more terminology about the circular economy principles. So when we are talking about energy, so we have to use the same energy in the multiple times. That is a circular economy principles. So even our papers also we have to mention about these the circular principles. Then the acceptance rate will increase. I mean, when you are working on this circular economy principles. So even when you're using material, we have to go for the circular times. Similarly, here is a MICP is a biocementation material. We can create in the laboratories. So this material, if you're using the sand converted into like a sticky material and like a cement can convert. When we are
Hello,
dealing
sir.
with the coastal zones, this
Excuse me, sir.
material is very useful. Absolutely, we were dealing
Sir,
with
sorry to
waste
interrupt you, sir. Sir,
waste management. So in the waste management, if you say Hyderabad, if you different area, yeah,
sir, your voice is not
yeah, please,
fully audible, sir.
please tell me.
Now somewhat it's clear, sir. Yes, sir, you can proceed.
Okay, okay. Sorry, here we commit there is a full net. Okay, okay. Thank you for the interruption. Basically, network issue.
Chandra sir, there is a lag is coming from your voice. The voice is reaching. We are not able to hear. Hello?
Hello.
Hi,
Chandra Reddy, sir.
just apologizing on behalf of Dr. Bujareddy. He is having connection issues. So we are truly sorry for the interruption.
No, it's okay. Ma'am.
He's trying to reconnect so he can rejoin the session. So please bear with him. Again, we do humbly apologize.
Yeah, no problem, Acha. Just our participants should be in. We need to wait for patiently so that speaker can rejoin again. He is facing some issue, I think.
Okay, sure.
Meanwhile, I'm requesting all participants to fill Google form for the attendance. And also please turn on your camera so that we'll took some screenshots. The attendance link is shared in the chat box. So all of you please fill that form. And requesting all participants to turn on video so we'll take a screenshot. Satish sir, please take a screenshot, sir.
Okay, ma'am.
I'm really sorry for the internet connection. Sorry.
No problem, sir.
Yeah,
So
thank you,
we are
Varsha. Yeah.
we are taking a small screenshot, sir, for with all videos. Meanwhile, no problem,
Okay,
sir.
okay, great.
That's
Thank you so much. So, when we are adopting this particular system, what is the use of to adopting all these systems exclusive for a geotechnical, a civil engineering point of view, as well as engineering is a possibility of the construction going to failure. Even road construction, even infrastructure road connection going to failure. Even if you are creating the industry areas, this problem is going to occur. But if you are adopting all the sustainable methods, then we can keep our structure in safe way. If you see Taj Mahal, when they built during that time, there is no issue with the settlement. So recently, there is one article is published about the Taj Mahal. So there is a one settlement is going to occur gradually, and there is a national, international, research scholar. They worked on particular Taj Mahal. Why it is going to occur the settlement? Nowadays, even if you see the so many ancient temples also, they slightly it is going to dragging. I mean, settlement is going to occur. It is really surprising for the researchers why Taj Mahal is going to, settlement is going to start it. So when professor from IIT Delhi, they approached the particular Taj Mahal nearby Yamuna River. So they noticed that previously they collect the soil sample, particular Taj Mahal location. This is going to occur.
Great, sir. Sir.
Student.
Excuse me, sir. Sorry for your
So climate action, the fluctuation,
Sir, there is a lag.
I had noticed the audio is not
The
properly.
audio is not clear, sir. I think better you speak slowly or take some measures, sir.
Oh, okay. Yes, sir, I think I'm still getting it. Okay. So in particular Taj Mahal, they noticed that the particular settlement why it is occurring, and they mainly adopted this particular climate action. They noticed that this particular Yamuna River, the fluctuation that started. Because during summer time, there is a winter time, the Yamuna River is rising and no complete river dry. So because of these reasons, the Taj Mahal settlement is occurred because Taj Mahal is built on in a pile foundation. That is a wooden pile foundation. So I hope you might be know that our ancient still in India practice is going. If you want to build the by using the wooden structure, we are soaking the wooden in particular water. No, if you soak the water in timber in particular water, the strength will gaining. But same things in Taj Mahal when this wooden foundation is sinking with the because of climate dry condition, the wooden is going to explore the climate thing and the settlement is going to occur. So he proposed the one copper dam in particular Taj Mahal. So they built a small copper dam nearby the Taj Mahal zone, particular. So no optimize. I mean they control the settlement. So that is the reason we have to adopt always our system with the climate action. So we have to protect our ancient constructions also. So by adopting the climate changes. So nowadays, even if you see in the Kerala, they're facing the huge issues about the recently we have seen the Wayanad flood system, unexpected Wayanad floods. Even just a few days back, very 1 week back, there is a huge floods in the Indonesia. So all these things because of these climate changes. So in exclusively in geotechnical point of view, civil engineering, so this climate action will occur, it indirectly affect on the particular foundation, and there is a foundation settlement is going to occur. Because if you see in India, you can see many varieties of the soils available. So each soil behavior accordingly. It's like how humans are there. Similarly, soils so many times are there. So these all the soil behavior differently. When we are during the coastal zones, so these the sustainable biochar as well the MICP, one of the most important materials. So I will try to show you about the how these two materials are useful, even as those who are research scholars from the multidisciplinary way, they can adapt these two materials. So how we can create the biochar is mean that you can collect any biodegradable waste material, and you can convert into by using pyrolysis method, and you can convert into the biochar. So those who are in the municipal solid waste, you can convert into the biochar, as well as the what are the all the waste materials like leaves, plantation things, we can convert into biochar. So by using this pyrolysis method, so it is completely purely sustainable thing. So we are not harming to any environmental things. So we are carbon emissions are completely zero. So there is so many multiple applications are there in particular biochar. If you see in the electrical, mechanical, in food sector, industry sector, exclusively agricultural sector. If you add this particular biochar into the plantation, so the main adoption particularly this material has the water holding capacity. So if you use this material to the soil, so there the possibility of the yield increase, particular paddy or whatever the material instead of artificial or harmful fertilizer, we can use the biochar. Many countries like in China and different Brazil, so many countries are adopting the biochar. In US also many people they are using this particular material. So for India it is very new for us. So we have to work on this particular materials. So in our particular research, so we are throwing the paper waste, it is also biodegradable material. So we collect these materials in the instead of throwing into the dustbins, the biochar. So those material we adapt in the to improve the soil properties. So these are the main some of the literature review about the paper waste. I'm sorry. I will show you straight away the result. This is at laboratory Shanta University. Once we convert the paper waste, we can see how the materials look like. So this material we can use into the material. So these are the property about the material biochar. So we have to check what are the index and engineering properties of the material. Then we can use the thing. So these are the exactly results about the how much cementation characters is going to occur, particularly this particular biochar. So I'm very interested in the research outputs. So if you see the index properties completely changing, so at 10% of the material we can get the optimum doses. So instead of by using by using optimum material, we can use in the to improve the soil properties. So even index and engineering properties also change at the 10% of the materials. So we conclude that this material is okay. You can useful in the strength characteristics to improve the strength characteristics. To create this material, we can generate the zero emission. Zero carbon emission, and it's completely sustainable material. This is one of the engineering material property. If you see the MSc material, so in India, once upon a time, very few researchers are working on the MICP. So till right now, only 10% researchers are working on this particular material. So this is one of the biocementation characteristic material. If you introduce this material into the soil as a sand, so multidisciplinary research, we can optimize the strength characteristics. So even we are working on the bioelectricity also. So we can convert into from the soil to the electricity also. In Japan also they create the electricity by the rice grains paddy. So, but now we are working on the by using this biocementation characters by adding to the soil exclusive sand material where we collected from the beach zone. So we creating energy from the particular material. So that energy also circular economy principles. So I will try to show you the results. So this is the one of the process to create the MICP material. If you are interested, I will share this particular process to you by personally. So I will just go through it directly, the result output. But this is the process how we can create this biocementation material. Okay, in our laboratory, we can create this simple steps within 1 day. We can work on this particular way, and you can store in this particular this entire biocementation material. So we can use in to improve the soil properties. So even though when you are dealing with the construction about this steel pipe laying on the particular ground surface, so we can use this particular material to control the corrosion as well as the erosion also. So this is the way we can create the cementation characteristics. I will show you the end result instead of the treatment process. So this is one of the important key research in our team. When you are throwing our waste, waste, so we can create the energy from this particular waste, by creating the, by gathering the gases, different, harmful gases. We can collect these gases and we can use in the other purpose. So for the reason, we using this particular MICP in biochar as a linear material here. Okay, and we can control the emission from the particular landfills. So for this purpose, we carry the Shandur zone particular soil sample, and we keep this particular layer as a treated sand by using the MICP and biochar. Okay, this both method we use is here the linear, I mean one layer kind of. So it can control the emission of the any gases. So that for that purpose we can control the climate action also. Suppose if you see in old exclusively in India, we are mainly focusing on the air pollution. So if you see the different zones, we are mainly we are mainly facing with the gases emission. I mean no air pollution. So these air pollution also almost 60 to 70% mainly because of the construction activities, either to create the cement or create some material, even by creating the steel material, and what are the construction materials required. By creating those things, we have to we are creating so much pollution. And as well as the when you are using the waste dumps, okay, when you're throwing our waste homemade or whatever the waste materials, harmful materials, so then they're collecting in one particular location. There is a waste management landfills are there. So when you are throwing all our material, again there is a possibility of chance of the gas emission. All these reasons is the influence on the climate change, climate action. So that is even if you see in Delhi recently there is a landfires that occurred in Delhi because of the so many gases emissions would occur. Then those gases is like creating the fire system. Even in Hyderabad and many other locations, landfill areas, there is a lot of gases going to emission. If you can check the air pollution particular zones, you can see the red zone particular locations. So how we can control that? So while throwing those materials, we can properly manage the waste landfill system, and we can keep our material into particular layer. Then we can control this particular gas emissions. So this is the main principle about this particular MICP, biocementation characteristics. So I will show you the end results. What are the objective here? So this is the main principle when you are adding these biocementation materials. For example, when you are adding the sand, so all this material going to interlocking between the particular MICP material, then we will get the more strength. So then there is no possibility of the gas emission these particular locations. So it will interlock the gas emissions. So that's the reason we can use this particular material in the landfill area. So these are the one of the key equations to control the permeability, especially gas permeability of this particular materials. So I will show you results how it can take it. These are all the equations for the permeability characteristics. Because when gas is going to emission, exclusively climate changes, we have to go for some equation that is a permeability parameter. So for exclusive for gas permeability parameters from the white space from between the particle, so those things we can control by the MICP. So these are the equations to create the charts. So the results is indicated that about when with respect to time when you're adding the material, drastically it can control the emission about the with respect to CO3 content. That means strength is going to increase. In shorter way, you can say that strength is going to increase and particle between particle going to interlocking. Then we can reduce the gas permeation, gas permeability, as well as the gas emission from the particular zone. So this is how you look like when you're creating in the laboratory. So this is the basic properties. So so here we can work on the suction characteristics also. That means we can optimize this gas emission from the particular soil zones by adapting this MICP material. So this is the gas permeability thing. So different. This is a base soil. BCS means the base soil, and is a 0.5 MICP and 1.5. So when you are adapting MICP, the suction, volumetric water content is going to decrease slightly. So we need to go for optimum doses. Similarly, you can see the suction characteristics also. Suction is nothing but when you are adding this material, it is going to sinking. Simply way it is going to sinking. So it is like a we can say like that when you are expulsion of the water from the soil sample, strength characteristic increasing by settlement. So if it is a more strength is going to occur, then automatically it can adapt to the system and we can control the gas permeability. This is the XRD result about the same result from the different proportions of MICP. This is the what is the strength characteristics from by using XRD. So this is the main pictorial representation. So this is the laboratory data. Whatever I shown the results, this is from the laboratory data. So this is the test result. And this is exclusively from the circular economy principle. That means that once we are adding the material, the same material again you can go for the second time. So that is called a circular economy principle. Nowadays in the UN, so they call for the papers on the circular economy principle. So by generating same energy, we can use the same material for the second time, third time, multiple times. So that is simply with the circular economy principle. But simple mean that when you are using the plastic waste, the same plastic weight, you can go for the reusable, the same material. That principle we call as a circular economy principle. So now, if you can use the both combination when we are in the pipeline system, how this is going to occur? How we can control the things. I will show here in a short time. So because if you are not dealing with the pipeline system particular material exclusively while dealing with the coastal zone, there is a possibility of the uneven settlement. There is a possibility of the breaking the system and possibility of the leaking the particular material for particular So on Penn G and myself we are working on this particular research work. So there is a possible, suppose if you are availing the plastic pipes, there is a possibility of the uneven settlement. So you can see the realistic picture how it look like. So how can control this uneven settlement and topsoil erosion is going to occur. So when you are noticing the steel pipes, there is a possibility of the complete erosion with respect to time. So but if you adapting this material and you can use the top layer and bottom layer and top layer and the covering material by using this MICP and biochar. So we can optimize this erosion, corrosion, and as well as the erosion both. So if those who are in extremely climate changes like Kyrgyzstan, even Canada, and China coastal zones, so we face a lot many issues with the climate changes. So this because of that, there's a possibility of the erosion and corrosion. So those two phenomena behavior we can change by using these two materials. So there is a possible leakage also. So those things also we can control by these particular materials. So this is our research is going on like this. If you see in experimental setup,
So we install the pipeline system here. We have installed the pipeline system here. So then we allowed the rainfall here, waterfall kind of. So then once this particular layer is a possibility of the erosion, particular this zone, and anyhow this particular pipeline system, saturation by the water. So then we are going to monitor the how much erosion is going to occur, and we are collecting here, and we have noticed the how much erosion is going to occur because of this coastal zone, because this tidal phenomena, there is a possibility of the erosion. The same situation, and the saline water, I mean, the particular ocean water have the saline behavior, that means the salty nature is high. So for that purpose, there is a possibility of the corrosion also. So those both phenomena we cross-checked here by this particular research. And another principle is the drying and wetting principle. So in our laboratory, we have the equipment like that. So we can have the temperature control equipment. So we can control the temperature at the drying and wetting processes. So for this process, we have to adapt the soil and soil plus biochar and soil plus biochar, and this both combination. And one is a steel pipe, another one RCC pipe. Okay, so when we are noticing the RCC pipe having a steel, and those steel is going to erosion with respect to time. Corrosion with respect to time. So these are all the parameter we have done research and particular this particular experimental process. So this is the way we install in the in laboratory, and we monitor the cavity how it is going to occur by using leakage process properties. For this purpose, we chosen the 1.6 centimeter inner diameter, outer diameter is 1.8 centimeter diameter pipe. So for both in the steel pipe as well as the RCC pipe. So this is the structure, I mean, a free body diagram for the erosion purpose, and as well as the same setup we use for the corrosion purpose also. So these are the leakage. I mean, we are going to give the different leakages. So once it is controlled by us, and we are monitoring the how much leakage is occur. Accordingly, how much erosion is going to occur. So similarly, if it is erosion is occur, then how much corrosion is going to occur with respect to time. So it is a nearly three years project. So we are working on this particular working, and PhD students are working on this. People, I mean, mechanical people, they might be interested of the corrosion. How we can monitor the corrosion, all these things. So this is the way we can adapt the pipeline system for particular pipeline system, corrosion, all these things. So, and we are wantonly creating the adoption, particularly to control the corrosion. So with respect to time, so because we are planning initially the erosion control. So once erosion is completely completed, then we are going to plan the in complete saturation point. We are going to control the corrosion also. So these are the main object of the particular research. And we are going to give the monitor the with respect to time, we are monitoring about the strength characteristics also at different loading points. So this is exactly how it look like in laboratories mean that. So this is the completely setup. So we are keeping the here this particular zone MICP plus soil, and we are operating the pipeline system here, and we are controlling the water path here, and we are monitoring the how much erosion will occur. So then we are just monitoring the how much soil is eroded from this particular zone, and we are collecting and going to weighing the particular samples, and we are going to create the small leakage phenomena on the at 2.8% and 36.8. This is the percentage of the whole, I mean, whole diameter is changing, then leakage is going to increase. So accordingly, we are going to check the how much settlement is going to occur. If you see that this is the settlement phenomena, particularly the soil sample. So similarly, once the complete erosion is occur, then we are going to monitor about the corrosion properties, particular these materials when you are installing in the coastal zones. So this is completely controlled in our laboratory. So we are checking, and additionally we are going to check about by using the image analysis also. We are capturing the each and every time particular photograph, and we are going to monitor about these phenomena in the image analysis. I mean, when you are giving, I mean, when input parameter, output parameters, so how the soil behavior is going to occur, and we are monitoring by using sensors how this pipeline system is going to change with respect to time. By using sensors, different sensitive sensors we are using, and it's completely this data is every second data, second by second data we are going to collect in the by the laptops, and we're collecting the entire information. And with respect to time, we are adapting the how much the drying and wetting, the climatic changes. I mean, how it's going to influence on the particular samples. With respect to time, how much settlement is going to occur in pipeline system, as well as the corrosion system. Once entire erosion is occur and we are monitoring the system, then we are going to check the corrosion. So we are about to end here. And currently we are working in the Thailand with Thailand process. So when in the coastal zones there is a possibility of the erosion because the climate changes, we are going to install plantation in the coastal zones. And once the same thing we are working in the laboratory. So we are planting the plantation, some of the kind of grass kind of, okay. We are going to plant it here. So once this particular period of the time, so this is the one period, second, different duration, the moisture with the respective moisture content. So once the experimental is over, with respect to time, we are collecting this sample to the laboratory and we are checking how much the root penetration going to occur. Suppose how it look like me. This is a soil sample. Because of these roots will it is penetrated to the soil sample, and we are applying the load. So how much load is going to changes by adapting these grass roots? We are working on it. So by using the saline water, if you are using fresh water, how the grass root is going to penetrate it? Exclusively when you are dealing with the slope stability. Suppose when you are making the no slopes, sorry. So sorry, when we are adapting the slopes, this kind of slope. So we need to fill the soil sample here. Okay, when there is a seabeds are in nearby coastal zones, there is a possibility of the erosion of particular locations. So that is the reason we are going to install this grass roots here. Then we can improve this particular soil from the coastal zones. Exclusively when you reaches the Tamil Nadu and the AP, as well as if you go the Kerala zone. So where there is a road paths in particular zones, there is a huge potential, huge possibility of the erosion of those nearby coastal zones. So we can control by using these concepts as well. Anyhow, we are going to adapt the stone pitching in this particular location. So additionally, we can adapt this particular MICP biochar, and we can check the how roots is going to increase. Accordingly, we can see how much strength is going to increase. So this is we are working at agricultural point of view. As well as we are working in the artificial intelligence. So with respect to time and with respect to input parameter, how the output parameter is going to change it with respect to different input parameters. So there we are monitoring with variation authors. So this is the key reference for a particular zone. I will just conclude within short time if you have time. So another thing is circular economy principle. So when we are going to publish the paper, I can request all the researchers, please know. So it indicates that it will give the sustainable development parameter point of view, and there's a huge possibility of the paper publication also. So here also what we are working mainly done. Anyhow, we are using the silty sand. That means that those who are nearby sand in the infrastructure completed. So same sand we can utilize for another infrastructures. So further season we are again adapt this single and double treatment of this MICP, and we are working on the circular economy principle. So our team is working on this principle. I will just show you how this system is very useful. So if you see some of the key parameter like relative density about the sand, If we adapt in the particular single time, if you go for multiple time, the strength is drastically changing. Even it can control the erosion and corrosion also with particular zones. Sorry. So these are the key parameters. If you adapting the single time and multiple times, and that is called the circular academic principle. The single time, if you are using the same material, the strength is going to change one way. If you are using the second time, the strength again is increased drastically. So all the properties like index and engineering properties of particular soil sample, by using this this MICP phenomena, we can reuse the same material. So that principle we call a circular academic principle. Okay, this is the main phenomenon is going to occur in the, if you see in the zoom point of view. So in single treatment, this kind of way it is going to occur. So when you are going to use the second treatment, so you can see the huge potential of the holding the two particles. So till now, I mean, about all the research about the sustainable development way and sustainable materials. And I would like to share the and if you are interested to go for the patent publication, either the varieties of patents are there, like design patent and the main paper patent kind of. So our team will help you in the you can collaborate the research point of view. Even if you go for the we are working with the Chinese professors, so we are so internationally we can we can do the collaboration research. So these are our main some few of the patents work. So because nowadays we are working on the smart way, okay. So by the multidisciplinary action, so exclusively when dealing with the climate changes. So one of the our innovation is like that. This is like a umbrella. So when you are keeping in the car as a mechanical or a triple, actually this paper is published on the 3 combination research, like a civil engineering, mechanical, and electrical. We worked on this particular drone umbrella, smart umbrella. So we are going to install this like army people. So if you just if you can allow the this umbrella, so you can protect the army people, whichever location is throwing the bombs, whatever the things is going to occur. As well as you can adapt to the same system in the car system. So whenever you are walking just away, it will automatically open and it can give the service to you, and again it will reach back. So these are the few patents from my laboratory. So still we are working on the few more patents. This all like a multidisciplinary kind of. So those are some mechanical, EC, and triple E. So different sector people they are working on this particular patent. So this is from my side. If you have any queries, you feel free to ask, and we can do some research collaboration if you are interested to on climate changes, exclusively civil or mechanical or triple E or some different sector. So in Indonesia, one of my colleague, one of my friend is working on the EC department. So he's completely working on the sensors. And in Kazakhstan also another department, they're working on the satellite things. Suppose there is a debris is coming back from the space, how we can control, where we can where we can safely we can reach the earth. So this all working in the one of the Kazakhstan student. So he's working on the how debris is reaching the earth, and as a geotechnical as a soil, we are working on the how we can strengthen those things, as well as the we are working on the moon soil. We are creating the in laboratory moon soil, and we are checking the how the dust pollution going into control on the planet of the moon. Even Mars also. So these all the things we can adapt from the multidisciplinary research. Exclusively, I'm really thankful for inviting me here, because I'm really interested on the sustainable development goals to explore climate change. I'm also one of the volunteer in the UN volunteers. So whenever they call for the UN some voluntary programs, we are going to reach those locations like South Africa, in Brazil, even in Kazakhstan. So we are working with the UN department, and we are working on the how we can control this climate changes. So mainly thing is we need the awareness to the students as well as all the research scholars. So exclusive to work on this climate changes. And one of the students, Varsha from the USA, she's also working on the UN, and she exclusively working on this plastic waste, how we can control this plastic waste to adapt the new materials. So recently in your Africa countries, so one of researchers they're working on this plastic waste converted as a bricks. So that is a internationally they register for a patent. So this way we can control the climate changes and for our future for our kids or children. So thank you so much for organizers. If you have any queries and we can discuss here. And actually sorry for my side as a network issues.
Yeah, thank you, sir. Satish, are you there?
Yes, sir.
Yeah, please go ahead.
Dear participants, if anybody is having any doubts, please you can ask the speaker.
Hello, sir.
Yeah, hi.
Sir, this is a composting enhancing process.
Okay.
How can we use this biochar? Hello, sir.
Yes. Even see, I think you are asking about the compost material. Yeah, I understand. I think you are asking about the compost material, right? Like a gobar gas kind of. I'm correct? Hello?
Alright, sir, come again.
Sir.
Your voice was breaking previously. Come again.
Okay. I think I understand the question that way. Mean how we can compost material, we can use this biochar. So this compost, yeah. So this compost material also we can convert into the biochar. Again, same biochar we can use in the agriculture point of view also. Agriculture research laboratory, there are the byproduct, even so municipal solid waste or this kind of the gobar gas product. Again, they're converting to biochar and they're utilizing some amount of this biochar into the soil and they're monitoring about how this plant growth is there. They really they surprisingly notice that when this percentage is going to increase, the whole water holding capacity is going to increase. So the same way the yielding is increasing. So this is one of the futuristic materials. So even if someone is interested of this particular, his question is, I mean, if you go for the additionally, so even sand, if you add the different percentage of this biochar, and you can see the plant growth in agricultural point of view. So that thing also we can monitor because we have the many sand deserts are there. So we can go for the plantation those zones. Even in China, there is a huge this kind of the locations are there sand deserts. Now they convert into this sand location to the green field. Yeah, thank you. I hope you got it.
Yes, sir. Anyone is having any other questions?
Nice presentation, sir.
Please, anyone want to speak? Please unmute and you can ask your questions, please.
Hello, sir. Is it audible?
Yeah, it is audible.
A very good, nice presentation from you, sir. We have learned a very grateful insights from you. And my question is, and what are the potential challenges of scaling up biochar production for the commercial use?
Yeah,
Hello, sir.
thank you. Actually, recently I've seen in Amazon also they're selling this biochar, but I'm not sure about the how much quality they're maintaining the biochar, and we are not sure what is the temperature they're going to checking. But those are like those are starting the new startup, they can create the huge amount of this biochar plants, so they can convert into the large amount of the biochar. I hope some people they definitely they comes to the industry way. So they can create the large quantity of the biochar and they can supply to the farmers. Even if you see, especially Rajasthan, if you go for in AP and some locations in India, so where after agriculture, they're going to give the 5 particular paddy. And if you see the, uh, exclusively for the rice paddy kind of thing. Instead of going to give the fire and we can utilize those materials into the, biochar, then it's more adaptable and it is completely sustainable. Yeah,
Yeah, thank you, sir.
thank you. Even from Rajendra Nagar, there is one agriculture university. One of the professors is working with us. So she is a very interesting about the biochar, and so we are going to, working both in the agriculture point of view, how we can create the maximum yield, optimum yield. So there's so many applications of this biochar.
I have one question, sir. What are the major challenges you have gone through in your process, in your research, when you particularly see through biochar or in your research work in Kazakhstan? The same kind of environment, if you see over India, what challenges we can encounter to do this kind of activity?
Yes, yes. I can share you one small, in our paper, we got some reviews.
Okay.
So we convert into the plantation to the biochar. So they're raising the question. So why you need to convert this biochar? This particular plantation to the biochar, because anyway it is a degradable material to soil. So why you need to choose this particular? And they raise the question about there is any certain small amount of the gas emissions will occur, even though we are going to use all the precautions. So we gave the reply for this particular paper. So that we noticed that we shared that this particular Indian real challenges. Once the paddy is over, so there is so many burning is going to occur, particular paddy things like so instead of going to burning, we can convert it. Instead of if you is going to occur by the process, at least climate changes. So then they agreed with us. The unwanted, agriculture, materials, we can convert to the biochar, by a simple process. So those we gave the reply. So then they accepted our comments. So these are the things we're going to encounter by creating a biochar. And another thing is when we are in the laboratory, so there is a difference is going to occur when you are keeping the same thing in the practical way. Because in China, we started small research on the hilly terrain. That is a few percent of the sand is there. So we sprinkled this particular MICP, like a 4 meters by 4 meter, and we collected the samples, and same thing we adapted in the laboratory. So for the both sample, we noticed because of maybe in laboratory we control the temperature, everything, but in the natural way, the temperature control is a completely different. So those things we notice some of the difficulties when you are adapting these materials in the realistic way. And we have another research proposal working on how we can control the dust pollution. So those who are electrical people, so they might be notice this kind of when you generating the electric from the solar panels. So we have main issue of the dust thing. Okay, so in China, we have proposed one research about entire completely all the particular location. We plan to sprinkle the MICP on topsoil, so we can optimize the dust pollution. So that we can enhance the strength. We can enhance the electricity thing. But when you are going where we can't control, when you are adapting the huge hectare. So that is also one of the big issues, challenges. But in future, I think we can overcome all these issues.
Yeah, thank you.
Hello.
Sir, can we use plastic waste also in biochar, sir?
No, we can't use the plastic waste into biochar actually, because of this plastic. When you convert into the biochar, again we have emission about the gas, some of the pollutions going to occur. So that is the
Okay.
reason only biodegradable material only we can use as a biochar material.
Oh, that can wood waste and everything we can use.
Correct. Wood waste. And one of my colleague, she's working on the in Brazil. She's working on the waste once from the waste so solid waste management. From our drainages, we collect the waste, right? That we can convert into the again a biochar.
Okay, sir. Sir, can you use
So those
MICP
things
for
we
the
can
ground
work, but
improvement technique,
plastic
sir?
we can't work on the.
Hello, sir. Sir, can you
Exactly.
use MICP for
Yeah.
ground improvement technique?
Yes, we can adapt. When there is exclusive sand deposition are there, or at least 50, more than 50% sand is there, then we can
Yes.
use this particular MICP.
Okay.
There is a multiple options opportunities are there, particularly this MICP.
Okay. Thank you, sir.
Thank you. Even if you have anyone have some innovation idea, exclusive of these two materials, so you may have some collaboration and research with the Chinese students as well the Kazakhstan students. One of my friends from Thailand, he needs some students, those who can interested to work on this MICP. So I can connect them with you for them. And in Shantu laboratory, again we are working on the bioelectricity thing. I will share one of the paper. So we can convert into the from the soil, we can convert into the electricity also. So recently there is one publication, essay publication. If you are interested, I will share those paper. You may work on in your particular specialization on particular paper.
Yeah.
In Japan, in Japan they create the electricity from the agriculture paddy, like rice grains. They create all the sensor to the rice grains. When they swing the things, they create. Energy is going to create it. So they create the additional energy from the agriculture point of view. So that is one of the interesting. I will share you if you are interested in those two papers.
Yeah, please share, sir. It will be
Please.
interesting.
Sure,
So
sure.
that
Thank you.
because then we can have the collaboration on this.
Sure, sure. I will
Yes.
share with you.
Yeah.
And you can share. Yeah.
Sir, we will please share to my email ID so that I can share to our participants and if it is a great part if you have a collaboration so that our center and our college will have helpful to our society, particularly our students community, so who are interested in this sustainable environment.
Sure, sure. And additionally, in this session, my student is there and my colleague. She is exclusively working the plastic waste. Even if someone is interested to working on the plastic waste, she will help you and she can connect to the UN department. So she is a member in UN department. She conducted so many programs on exclusively on the plastic waste. So we are working both together since long. So if you are interested, I will connect with her and she can share some few points about this research collaboration if she is there. Varsha, are you available?
Hi, yes, I'm here.
Yeah, can you please share
Yes.
few points if you are, somehow we can do collaboration research.
Yeah, sure. I can share my email address. Is that okay?
Yeah, please.
Okay, I'll put it in the chat.
Thank you, Varsha, for joining with in our team. I know you're too much busy with it, and the timing also changed. So thank you for joining with us.
It's been my honor and pleasure. Thank you also.
Varsha, could you please share your mail ID details so that I'll connect with you?
Okay, I just sent in the chat. Please let me know if you received it.
Okay. Participants, if you have any questions, you can ask now, or otherwise we'll go to the next session. Satish sir, please continue.
Okay, madam. Thank you. So it was very nice presentation, sir. So thank you very much for being with us today. So once again, good evening to everyone. So it is my privilege to deliver the vote of thanks on behalf of Department of Mechanical Engineering KGSA. On behalf of all of us here today, I extend my heartfelt gratitude to Dr. Chandrabhog Reddy sir for taking the time to share his expertise and knowledge with us. Your presentation was both thought-provoking and inspiring, sir. The insights you provided regarding climate change and importance of the environment have certainly given us new perspectives and the valuable key takeaways that we will carry forward in our professional and personal lives. Thank you, sir. Thank you for us giving this opportunity.
Yeah,
So-
thank you. Yeah, I will go so last to a few words, and thank you so much for giving this opportunity. Exclusive principals are head of the department and the research R&D dean, and thank you all, and thank you to my all students, and thank you all the participants for giving this opportunity. You are most welcome at any point. We can do the research collaboration. Thank you so much.
Thank you, sir. So the participants, please, you can give your feedback of this session one, so that I already put in the chat box, so that we can move to the next session.
Yeah,
So
participants, Satish,
to the next moderator, Mr. Anil Kalluri. Sir, take over to you, sir. Anil, sir, are you there?
Yes, I'm here, sir. Thank you, Satish, sir.
Anil sir,
Am I audible to you, sir?
Yeah, you're audible, sir. I request
Yes, sir.
participants to give the attendance part and also the feedback compulsory. It's mandatory from the AICT, so it's very important to share your feedback and also the attendance part. Thank you. Anil sir, please go ahead.
Shall we start the session too, sir? Yes, sir. Thank you, sir. Good evening to everyone present. Myself, Kalluri Anil, Assistant Professor, Department of Mechanical Engineering. Welcome you all for the session 2, Future Directions, Innovation, Policy, and Leadership for Sustainability. Now, it's my privilege to introduce our session speaker, Dr. TVV Maruti Suman Garu. He is a freelancer, consultant at Energy, Environment, Climate Change, and Carbon Market. Dr. Maruti Suman Garu holds a Bachelor of Technology from Gayatri Vidya Parishad, a Master of Technology from Jain College of Engineering, Anantapur, an International Honorary Doctorate in Environmental Science and Technology from World Human Rights Production 2021. Coming to his job profile, Dr. Suman Garu having 18 plus years of result-oriented professional experience in construction industry, climate change, and sustainability execution of 132 kV and above transmission lines, and with project management skills in planning, scheduling, and monitoring, and validation of Global Carbon Council in renewable energy projects. And he worked in many reputed organizations like as a senior engineer at Deepak Cables India Private Limited in Bangalore, Deputy Manager at Kalpataru Power Transmission Limited in Gujarat, and also worked as an auditor for the Epic Sustainable Service Private Limited, Bangalore, and as an auditor for the Global Carbon Council Renewable Energy Projects at KBS Certification Service Private Limited, Haryana, India. And he has worked with many more companies and many more organizations. With this brief introduction, now I am handing over the session to esteemed speaker, Dr. TVV Maruti Suman Garu, and welcome you, sir.
Namaste all. Namaste. Andy. First of all, I thank Samyukta madam for the opportunity and engineering college staff and team for this opportunity to deliver my experience, what I learned from sustainability and all. I'm looking forward to it. before going to session, actually, before going to session on the topic, I actually want to have the session two-way, not only I speak and you listen and like that. I want a two-way interaction on the topic because this is a wide topic. Everybody has own meaning on sustainability and all because now it became a buzzword. Sustainability in every life, sustainability in life, sustainability in everything. That's that's why I want to, before start of the session on the topic, I want to have the audience who are listening this seminar. I want to know their point of view, what sustainability means to them, and how they want to, how they react. Before going to session, I want to know. Anybody can unmute and
Yes,
Yes, sir.
yes, sir, it is audible.
hello.
Yes, sir, you're audible, sir.
No, I am asking the audiences who are participating in this seminar. I want to know their point of view or what they mean of sustainability and all, because now it became a buzzword and now everybody is telling sustainable lifestyle, sustainable living, sustainable development, sustainable everything. It needs to become
Sir,
a daily
sir,
way
I would like to, sir, I would like to talk about the sustainable thing.
I want to know
Sustainability.
from audience. I want to have interactive, say, two ways. Hello, you understood my
Hello,
question?
sir.
Have you got my
Sir.
point?
Sir, can I speak?
Yes, sir. Yes, sir. One
I want to
participant
know
is
what
wanted to
is
talk.
their
Sir,
view
sir,
on the
sustainability is defined as the meeting the requirements of present population with their sustainability and also hand over the safe future for the coming generations. That's how we define the sustainability in our nature. Thank you, sir.
Sir, sustainable
anyone?
means, hello, sir. Sustainability means long-standing of the anything, sir. Either construction or any activity should be long-standing. Without of their function and property should not be changed.
Okay. Anyone?
Yes, sir. Sir, I want to ask one question. How does a sustainable agriculture reduce the overall impact of the farming on the environment?
Okay, that my topic is given on a different thing like policy and all. Later at the last end of the session, I will try to answer your question because I don't want to deviate from the topic given to me. Okay, then means sustainability means in a simple language, sustain plus ability to survive. Sustain means survive. In a simple words, in a layman language, ability to survive. There are so many definitions. I accept all the definitions because it means everything to all in a different way. But ultimately, our goal, our thing is how we can survive, ability to survive. Can you please share my presentation? Hello.
Sorry, sir, are you available?
Yes, sir. Give me 2 minutes, sir. We will share.
Wait 2 minutes.
And my session will be I expect interactive one because it is a different topic. It is That's why I want to give insights.
Anil
based
sir,
on my
please share
experience and-
PPT.
Okay, ma'am, I will
And
give you 1
anyone can
minute.
interrupt me. Anyone can interrupt me on the due course of the session, and you can ask me or you can tell your views or anything on the presentation. Or I want to confine to the presentation and the topic, not deviating from other things, because it is an interlinked concept. Sustainability is interlinked concept. And that's why I want to go with the session topic mainly. Okay.
Sir, I hope PPT is visible, sir.
Yes, yes.
Yes,
You
yes,
can
sir. You
make
can
it
continue.
bigger. You can make
Bigger
bigger
one, sir.
screen.
Now, sir?
Now it is okay.
Yes. Yes, sir. You can continue.
Actually, I have given the topic future directions, innovation, policy, and leadership for sustainability. That is the topic given to me. Actually, the topic is a very broader thing: innovation, policy, and leadership. These are the main pillars or the future direction we have to look upon, because innovation is required, policy support or policy changes are required, and leadership is the main thing for sustainability, because until unless the top management recognize it and take it forward, we cannot do anything. The support from the top management, leadership is very important for sustainability, and it is a forward-thinking approach to address global sustainability challenges. Now the world is experiencing the merit of experiencing very changes, climate changes, everything, and we are experiencing. It is real. We cannot deny the fact that the climate change is not real. There are some people who are contracting it, but you can see the IPCC report, Intergovernmental Panel on Climate Change, and science-based targets. They are telling now we have crossed the threshold of 1.5 degrees from the pre-industrial level. Now we are moving ahead to 2 degrees centigrade. Then the scientists and researchers are telling this we cannot reverse it. It is time to act now, and there is no way we can just mitigate it by adaptation, climate change, and all these things. And it is now it is very high time, and all the people from different stages of work, like policymakers, politicians, governments, and future youth of India or youth of world, and like organizations like engineering colleges and like that, and all have to join hands and work for a better future. That is the only way we can go forward and look for our future generations to live in a good way. Actually, sustainability, it is already there in our ancestors, and now we have to go back to our roots. That is the main thing. But due to now, because of human man-made effects, we are experiencing, it is now visible. Now, every day we are experiencing something. before it used to be happen only yearly wise or like that. But now we are seeing, experiencing, and every day something is happening all over the world. Like it became common. We are experiencing it. Coming to my topic, below, regarding to innovation for sustainability, main thing is technological advancements. First page, second page. I will tell the next page to them, you can change it. For innovation, technological advancements are very important. In that one, renewable energy innovations, breakthrough in solar, wind, and storage technologies. Nowadays, battery energy storage systems are becoming more. They want to integrate battery energy storage system technologies and pumped storage and hydrogen, green hydrogen. They want to integrate the research is going on, and so many things are becoming pilot, and renewable energy innovation plays a very important role to reduce the energy dependence. Because why this concept has came? Because demand side management. Whenever there are two types of management, one is supply side management and another one is demand side management. Supply side management is not, we cannot do, because whenever demand increases, we cannot increase supply. Supply, how we can increase? That's why demand side management. Whenever the demand is increasing, we have to adjust, use our resources judicially, consciously, and so that by use of these technologies like energy efficient technologies, renewable energy, demand side management tools, and all these things, so that the loop will continue. The output also will increase, and we can use the finite resources available. Judicial use of resources, energy efficient technologies. For same output power or more power, we can use less input energy and make the system energy efficient. Energy efficiency, and also decarbonization strategies. How to reduce the emissions, CO2 emissions, and all these things. Renewable energy is one of the things. And circular economy, as our previous speaker told, circular economy technologies are very important now. Advancements in recycling, upcycling, and material recovery. These plays a very major role because our resources are finite. We are exploiting the nature and digging, and there are estimates that after some coal, after some 100 years or 50 years, we cannot find it like that. The resources are finite. We cannot continuously do these things. Okay, we are exploiting the nature and all. And another one is AI and data-driven solutions. Nowadays, all of us know the future is AI, artificial intelligence, and data-driven solutions for optimizing resource use, predictive maintenance, smart city infrastructure. Now, world is looking for smart city. Buzzword has become smart city. Our government also has smart city mission and all. And next IPCC report is coming on the smart cities, how to make cities resilient and climate sustainable and all. The IPCC report is coming on next topic on this. And next, system thinking. We need a holistic approach. Just not only one angle, like suppose before what we used to do, only financial, if it is financially viable and if it is benefiting some people, the project is started and all. Now we need a holistic approach on parameters like environment, social and governance also. we need a holistic approach for development or anything, integrating technology, society, and environment. Environment for clean air, clean water, clean air, and all these things, environment. Society, the local people who are affected without considering the people of the we are ignoring them or going forward. Already we have so many issues like
Excuse me, sir. Sorry for your interruption. Hello.
hello, previous slide.
Sir, your voice is not audible, sir,
Previous slide.
and it's not clear.
I am audible.
Yes, sir.
Hello.
Yes, sir, you're audible
I'm
now.
Yes, sir. You can continue, sir. Yes, sir. You can continue, sir.
Okay. And for regarding policy, policy means like regulatory frameworks, policy promoting carbon neutrality, net zero, carbon positive, renewable energy targets, emission reductions. Our India already per capita emission reduction of per GDP is very less. Even though India is number 3 in high CO2 emissions, but our with respect to GDP, our emissions is very less compared to developed countries or like that. In that way, we are very much forward, and our renewable energy capacity addition, we have reached our targets before 2030, and we are moving ahead. Our government is taking steps and new policies and new things. Recently, our Prime Minister released carbon credit trading scheme, and so many initiatives are happening. One is decarbonization strategies, energy efficiency improvement. These are all policy things. How this is very important, because until unless the policy is framed and it is integrated into the system, we cannot take it forward. And also tax incentives. Recently, our finance minister, as you all know, carbon taxonomy. What are the high polluting industries? They want to tax carbon tax, so that they will take decisions and to pay, they can reduce the tax or they become green and all. Government is coming up with carbon taxonomy. Our finance minister Nirmala Sitharaman, in the recent budget, she announced, and things are going ahead. Green technology adoption and penalties for pollution. Tax incentives also they are planning. And next is international cooperation, global partnerships, and collaboration with universities, youth, involving youth, and so that like Paris Agreement and all, and harmonizing sustainability goals across nations to address transboundary challenges. You know, United Nations has 17 Sustainable Development Goals. They are, we are actually sad to say, by 2030, we are unable to reach the targets, but things are, we are having a positive hope, and I think we are moving ahead. And for this, all should come forward from the industry level, from the society level, individual level, from the government level, from policy level. Everybody must join hands. Then only we can see our better future, greener planet, and everything. Then another one is equity-centered policies, inclusive frameworks, considering marginalized communities. As already I told before, the marginalized communities, those people must be taken into loop and they have to consider. Otherwise, and indigenous knowledge systems, strategies to bridge the gap between developing and developed nations in sustainability efforts. Now, all world is same because we are having a common atmosphere. We cannot say my area is protected, we are less CO2 emissions, and another area, developed countries, they have, it is common, atmosphere is common. We are all breathing same air, we are drinking same water, same everything. Just the reasons are different, but ultimately you have to bridge this gap and you have to work in coherence. Next slide, please. And coming with leadership, visionary leadership, leaders who champion sustainability as a core value in decision-making process. The top management, the decision-making people must take this opportunity and consider the sustainable development goals and involve all the people and take the feedback and all these things. Encouraging collaboration across sectors to achieve systematic change. Collaboration also I mentioned. Education and capacity building. This is the main important thing because I am also during my studies and all, sad to say, I also don't know where I am living, what are the water table available, what are the things, pollution happening. I am unaware because we are only bookish and we don't know our surroundings and all. We are not given that much importance. But now it is time. The education and capacity building must must be given more importance, especially the youth, the future of the country or world. Developing future leaders through sustainability focused education programs. That is very much important, like involving the youth, having connecting to nature, and like that you have to design programs and work on the grassroots level and involve discussing with communities, involving communities and all that are very important. And another one is promoting public awareness campaigns and professional training on sustainability issues. This, I think, your engineering college can take the lead, and there are so many persons, experts like me, or there are so many people you can involve them and to take this movement forward, mass movement. Our Prime Minister already given the thing mission life, lifestyle for environment. You have to take it as a mass movement and not only by campaigns and social media and all, that is also required, but we have to work on the specific issues locally and act locally and take the issues, and you have to work together. Then only you have to educate the youth, educate the people around. What are the myths and facts? So many myths are there. You have to show the proofs according to science and all. And there are so many experts in the field and so many reports. In this way, your college and this Atal Mission program can take the lead. And corporate sustainability. This is for the corporates, CEOs and business leaders as sustainability advocates. They have to lead the show because suppose if Ambani or anybody tells something, the world will follow. Everybody take it into attention and they think it is correct. That's why they play a major role. Suppose if Anand Mahindra tells something or he posts something, everybody will think, "Oh, okay, it is correct," and that's why in the way they impact the things. Transport reporting, transparency in reporting and adherence to ESG. Transparency is very much required, and ESG, all you know, environmental, social, governance standards. Next slide, please. And key future directions, interdisciplinary collaboration, building bridges between science, business, policy, and grassroots organizations. This is very, very, very important. Building the bridges between, now we are working on not in a foreign way. Everybody is working at their own level, own way. Now we have to bridge this gap and integrate all the things, science, business, policy, and grassroots organizations. Encouraging innovation ecosystem where diverse stakeholders collaborate. Suppose some companies working on the new solar, they have to work with research organizations, involve youth, and see how it is benefiting the system, what improvements we can do, and all these things. Innovation ecosystem where diverse stakeholders must collaborate. Adapting to climate change. This is the only thing we can do. Strengthening climate resilience in vulnerable regions. Policies and technologies focusing on mitigation and adaptation strategies. And final thing is measuring and scaling impact. This is the main challenge now world is facing. Measuring, you have to have a, we can able to measure it. How much tons of CO2 is emitting, what is the impact. We have to have quantify it and measure it, and so that we can see the things. Otherwise, just by telling, and we cannot convince the policy makers or politicians or anyone. This is very challenging, and now some methodologies, guidelines or standards are available. We can take that use, and scaling successful models through policy alignment and private sector engagement. And this is the very important thing. Nowadays, private sector is leading the way in everything. Like suppose if you take artificial intelligence or using drones or all these things, private players are taking the lead, and we can able to achieve the goals, sustainable development goals or whatever the things. Successful models also through policy alignment. Nowadays, government is coming with different policy interventions, encouraging the youth or industries, players, or everyone. Like is a good example is PM Surya Ghar Yojana by our Prime Minister. He wants to the vision to install every solar panel in the rooftop of all our houses. His vision, and that is one of also good policy. Like I'm giving some examples. I think next slide. I think and cultural shifts. These are very important because culture also plays a very crucial role, social, shaping societal values towards sustainability, normalizing eco-consciousness consumption and production behaviors. This is also very important. We should become environmental consciousness, behavioral change. How we think and behavioral change. If you simple step for emission reductions are becoming sustainable is behavioral change. If you adapt to minimal living, we change some basic things, small acts, we can overall we can achieve some 10 to 15% emission reductions or greener planet, sustainable way of living or this thing. This is the simple step. Small acts, less pollution to environment, behavioral change. Suppose now, for example, I am using cotton cloths, or now I am not ironing my clothes regularly. Like that, some small steps, changing to uh, nowadays so many sustainable products are available, less harm to environment, and this plays a very important role. I think these are one of the things I want to share, and thank you. Anybody has views and things? Because I am also learning, it is a whole entirely things are evolving and new things are coming, and we are changing drastic things and all. And this is an open forum, and I also want to learn from you and all these things, whatever is this thing. Ultimately, our goal is sustainable way of making it is a way of life. Making sustainability as a way of life. We have to incorporate in our blood and all, so that there is no any shortcut to sustainability or all these things. Our ancestors are they shown the way and everything. Now it is time to go back to our roots and take the lead. It's time to act now. Thank you. Hello. Hello. Hello.
Hello. Yes, sir.
Yes, sir. You can. I finished my presentation and my views. Anybody are interested, and you can ask anything, or because this is an interlinked system, all these things are interlinked. We cannot tell sustainability only in agriculture, sustainability only in energy, our lifestyle, like that, because all are interlinked. It is a wide concept. Anybody wants to ask any questions, or you can give the feedback how your views, and so that I can also improve and make it things better.
Any questions from the audience, please?
And anybody knows about the recent SEBI guidelines on BRSR, business responsibility and sustainability reporting, and recently ISO standard has released on ESG, and so many things are happening. Now top 1,000 listed companies in India, they have to file BRSR report and all these things. Sustainability reporting, carbon footprint assessment, GHG accounting, greenhouse gas accounting. There are standards, ISO standards, ISO 14064, 123, to calculate the scope 1, scope 2, scope 3 emissions. so many things are there. I cannot discuss in this seminar now. Anybody wants anything on GHG accounting, carbon footprint assessment, carbon markets, or sustainability reporting, ESG, or anything, you can contact me. I shared my mobile number and email ID in the first slide. You can contact me. I am working with so many organizations on various things. You can contact me for any help or any information on what is happening in India and the world.
Dear participants, is there any questions to ask the resource person?
I hope I done my best, and I am.
Hello, sir. So recently one project launched by the hydrogen, sir, at Vizag. Sir, is it any impact on the other resource of energy, sir? That is solar energy or wind energy?
No, actually, all these technologies, renewable energy technologies, why we are, it is needed because we want to become energy independence. We are importing oil, it is becoming burden, and our resources are finite. That's why we are looking towards all these things like solar, wind, green hydrogen, and all these things, lithium, and all these things, thorium, nuclear reactor, and all. Because and also the coal, oil, gas, these are high emission CO2 emission materials. Large amount of CO2 is emitted by burning coal, oil, gas, and all. That's why, and also the importance is we are becoming energy independent and self-sufficient. We are importing, suppose if we see statistics, we are in India, we generate only some 20 to 30%. Another 70% we are importing from Saudi Arabia, like that. Our energy bill is, import bill is very high. To reduce it, and as our vision of our Prime Minister to become energy independence by 2070, these are all very important. Our India is having so many solar is abundant, green hydrogen, and all these things.
Okay, sir. Thank you.
Sir, can we have any policy after, for example, solar panel lifetime is 15 years? After 15 years, how can we recycle that? Everybody is talking about solar and sustainability energy. But after using that,
that's why-
how can we recycle that?
Yes,
Is there any recycle processes available already? Any policies coming out from the government to recycle those?
Actually, policy think tank is also to extract the precious metals from the after the lifetime of the solar panels and all. In China and all, they are there, and in India also they are doing, and mainly they are doing at the industry level, at the manufacturing level they are doing, but at the consumer and like that, it is still we are requesting the government to encourage some policy changes for the these things, because it requires huge amount and all for recycling and all. And for this, IISc is working on this project to how to, after life cycle of the solar panel, how it can be uh, recycled, upcycled, and how it can be used. There are so many organizations are working, and policy intervention also there are there. Recently, some new laws are coming, and yeah, people are also thinking on it. But at the manufacturing level, the industries are doing. They are not, because it is also cost on them. If they use extra material or like that, they are wanting it to reuse and like that. And also government of India coming regarding the vehicle policy, they came swapping uh, policy has came, and for solar panels also they are working like same like wind energy after the lifetime of the project, how to uh, utilize it and all. They are working. Things are moving ahead.
Okay, sir. Thank you.
Hope
Sir, I have
Pa-
one, Samyukta ma'am.
Sir.
Yeah, based on the leadership and organization culture, if you see, what strategy we can employ to integrate the organization culture and the sustainability. So the faculty committee can learn, and they can work it on and see, and it can pass to the next generation.
like as I told in my previous slides, the top management are the at all levels, like individual level, at the every level, all must be involved, become conscious, behavior change, and also there is a need to capacity building and education, because uh, there are so many myths and false things are coming. There are science-based targets. There are so much material and all, and we have to work locally and work at the grassroots level. We cannot. There are reports and all, but ultimately we have to work at grassroots level and make the things locally, and there are solutions. Capacity and education, capacity building and education is one of the main thing, because for our future generations and the future youth of India or any country, these are the people who will be most affected, or they are using the resources more compared to our generation or before generation. That is very important.
Yes.
And at all levels, suppose you take waste management or waste segregation or like that, every individual must think and do segregation at the individual level at your home, then next community and all. There are so many options nowadays. There are so many things available. They can start with small acts, and they no need to think of big things, more investment or like that. There are so many options. You can start with small acts. Some are available, and now so many startups are coming in. So many new technologies, new innovations. Like that, we have to work in, not silos. We have to work in tandem so that all will get benefit. At the research level, something is happening. At the industry level, something is happening. At the education level, something is happening. But it is not correlated or interlinked. That is the main problem. Policy people, they are thinking on the policy side, how to become energy independent, how to make it to increase development and all. They are thinking at that level. And industry level, they are thinking their benefits, how they want to grow and all. And education side, research side, they are thinking at different level.
Yes, sir.
It is not ultimately coming to the prototype or commercial or like that. That is the gap. We have to bridge that gaps so that and nowadays all are open. If you have some idea or want to work on it at the world level, this is the main topic nowadays. And all are looking for feasible solutions to you can see SDG goal number 17, partnerships, and that one already it is in the SDG goals, SDG goal number 17 for collaboration and partnership. United Nations already noted and it is there. You have to take the initiation and
Yes, sir. Thank you,
have
sir.
to go
Thank
forward.
you, sir.
Got it.
Thank you, sir. Anil, sir.
Okay, ma'am. Dear participants, do you have any questions? I hope everyone is clear and from the audience there is no questions.
You can reach out to
Can I
me
continue, ma'am?
and I have my phone, email address and phone number.
I
Yes.
will share,
You
sir.
can
Your
reach out
mail
to me.
ID and that I will share with all participants.
Okay.
I have.
Yeah, go
I'll
ahead.
share.
Thank you.
Yes,
Thank you, sir. Thank you, Suman, sir, for accepting the invitation and spending this evening time in your busy schedule also. Thank you so much. And on policy side, they were to explain all type of sustainabilities in policy side. Thank you so much for your enlightenment. Thank you, and all the participants, thank you for attending the sessions.
Thank you.
Thank you, sir.
Before leaving, I'm requesting all participants, please fill out second session attendance and feedback forms. Thank you all.
And they can open their video. We'll have a screenshot.
Requesting all participants to open your video, to turn on your video so that we can take a group picture. Jayahari, sir, I hope it's done, sir. Screenshot.
Yeah, it's done. Anil, sir, I think it's done.
Anil, sir,
Yes, ma'am.
it's done. We can close the session, sir.
Yeah.
Yes, ma'am. We can close the session. Thank you, sir.
Thank you, Suman, sir. Thank you, all the participants. We will meet tomorrow evening, same time. Thank you.
Thank you all. We are closing this session for today's session, and we'll meet tomorrow exactly the same time. Thank you. Sorry, sir, you can close the meeting.
Okay, sir.